This is problem 8E on the practice problems for test number 1. A riverboat took 4 hours to travel 48 miles upriver against the current, and then 3 hours to return downriver with the current. Find the speed of the current and the speed of the boat in still water. So we did problems like this in class, and we made a table to try to organize the information. So if you haven't done so already, go ahead and pause the video here, make your table, and then come back. Okay, so if you're back, you've got a table. Hopefully it looks pretty similar to the one I've got here. We're going to need columns for rate and time and distance. I always put them in that order. And then we need 2 rows for this table because we've got 2 journeys we're traveling on, one upriver and one downriver. So what do we have here? So we need to know the rate at which we travel upriver and the rate at which we travel downriver. Well, actually, those things are very much related to the things we're trying to find here, the speed of the current and the speed of the boat in still water. So even at this stage right now, I think we need to introduce and define some variables before we do anything in the table. So let's go ahead and define our variables. Variables are going to be right here, the speed of the current and the speed of the boat in still water. So I'm going to let C equal the speed of the current. And I'm going to let B equal the speed of the boat in still water. You're welcome to use X and Y, but I think it's better to use letters that maybe more represent the variables they stand for. Okay, so now that we've got that, we're ready to start filling in the table. Let's look at the first column again, the rate. So I want the rate at which the boat is traveling upriver, and then the rate at which the boat is traveling downriver. So upriver means the boat is going against the current. So normally if the boat were in still water, its rate would be B. That's what we call the speed of the boat. But the current is working against us in this case, so whatever the current is, we're going to have to subtract it from B. So for example, if our boat could normally do 8 miles an hour, but the current is 3 miles an hour going against us, then I think all told, we'd only be going 5 miles an hour, right? 8 miles normally minus the 3 from the current would give us our actual speed would be 5. And then when we go downriver, well, again, normally B is our speed in still water, but in this case, the current is helping us. So it gives us an additional boost of C miles per hour. Okay, the times are easy because they're given in the problem. So it says the time going upriver is the 4 hours, and the time going downriver is 3 hours. And then the distances, well, actually the distance is given as well, although I'm not going to fill it in here. This is just a personal preference of mine. What I like to do when I fill in the last column is just multiply the first 2. Rate times time is distance. So 4 times B minus C, and then down in the bottom, 3 times B plus C. If you fill in your tables in a consistent way, if you label the columns in a consistent way, then to find the last column, you're always going to be multiplying the first 2 for the problems that we've been doing in this section. So let's see if we can get some equations now. We have not yet used the 48-mile trip, so that's what we'll do here. I know that the distance going upriver is 4 times B minus C, but I also know that that was 48. So there's my one equation. And then the downriver trip distance here was 3 times B plus C. Now there's no other number given in the problem about the distance traveling downriver, but there is one word that tells you what it is. It's that word right there. Because we are returning, the assumption is that we're traveling exactly the same distance coming back as going out. So this is also 48. Okay, so we've got this system of equations to solve. You can use elimination, which is also known as the linear combinations method. You can use the substitution method. I'll tell you what the best thing is to do is to divide the top equation by the right number. And the right number in this case is 4, because if you divide by 4, the 4 cancels on the left, and 4 goes in evenly into 48. You can divide the bottom equation by a different number, and these 2 equations will become much simpler than what we're about to do. So we'll come back to that shortcut way, but if you want, you can pause the video here, follow that shortcut, and then come back. We're going to do it assuming that we didn't see the shortcut. So let's do this without doing any shortcuts. So I'm going to distribute that 4 through. 4b minus 4c is equal to 48. And also distribute the 3. 3b plus 3c is equal to 48. And what makes this annoying is that if you're going to use substitution, it means you have to solve one equation for one letter. For example, if you decided to solve this equation for b, at some point you'd have to divide everything by 3, which is going to give you some fractions, which I guess we can handle. Well, maybe we won't get fractions because the 3 goes in evenly, but still I get reluctant to divide everything by a number because usually it's fractions. If we do the elimination method, well, we're going to have to multiply both equations by something. So we're going to try that. I'm not saying it's easy, but let's see if we can't get rid of the c's. I want these guys right here to cancel out. So currently I have negative 4c and positive 3c. I'm going to turn the top one into a negative 12 and the bottom one into a positive 12. So what do we multiply the top equation by to turn it into a negative 12c? Is times 3. What do we multiply the bottom equation by to turn it into a positive 12? Is times 4. So let's put them down here now. Top equation, the 3 distributes all the way through. 12b minus 12c equals 144. The bottom equation, the 4 distributes all the way through. 12b plus 12c equals 192. And then what should we do with these two equations? We should add them, because when we add them, something very nice happens right here. The 12c's cancel. So we add the b's, there's 24 of them, equals, we add over here, 336. And finally, we're ready to say what b is. Divide both sides by 24. And do that here. 336 divided by 24 is equal to 14. So 14 miles per hour is the speed of the boat in still water. And then to find the value of c, you're going to want to go to any of the original equations. For example, I'll go to this one right here. 3 times b plus c is equal to 48. So instead of b, we're going to put the number we just found, 14. Okay, so again, best thing to do here is divide by 3, but if we don't see it, if we feel obligated to distribute that 3, then we will. 42 plus c is 48. Something is funny. The funny thing is that I didn't distribute the 3. Plus 3c. Okay, and then we'll subtract the 42 from both sides. And then finally divide by 3, and we get c is 2 miles an hour, which is the speed of the current in still water. So we've got our answers. Just put them over here in one spot. So 14 miles per hour is the boat speed in still water, and 2 miles per hour is the current speed. So that's fine. We're finished with the problem, and you can stop watching the video if you wish. But if you haven't taken the time to do that shortcut, then this is a good time to do it, because it really is worthwhile if you see it. So I'm going to go back to the 2 original equations here. These ones right there. I'm going to copy them down at the bottom, but now we're going to do the shortcut, and we're going to see how much nicer this becomes by doing that shortcut. So let's copy those equations down here at the bottom. So we had 4, b minus c equals 48. And then over here, 3b plus c also equaled 48. And the trick that we saw was that we could divide everything here by 3, everything here by 4. So what happens when we do that? Well, let's see. Maybe I don't want to put them in one fraction. I'll be really clear here. We're dividing both sides by 4. dividing both sides by 3. And let's see what we get left over. So if we divide by 4, that cancels, and this goes in evenly 12 times. This cancels, this goes in evenly 16 times. And so we get the much nicer equations, b minus c equals 12, and b plus c equals 16. I'm going to go ahead and copy this one right down underneath so they're next to each other and looking familiar. And to solve this system of equations is much, much easier. If we add these two equations right now, the c's cancel, and we just get 2b equals 28, divided by 2, b is equal to 14. Sounds familiar, that's what we got for the speed of the boat before. And then to figure out what c is, use either of the simple equations that we've got right up here. We know that b plus c is 16, but we just found that b is 14. So b plus c is 16. Subtract 14, we get c is equal to 2. So much, much better if it happens that you see that shortcut.